In a Space News episode earlier this year, we reported on the mysterious sounds associated with electromagnetic phenomena in Earth's atmosphere. In addition to centuries-old accounts of strange noises apparently connected to earthly auroras, we discussed the electrostatic noises reported by some witnesses of spectacular meteors. Today, a new scientific study published in the Geophysical Research Letters argues that the sounds associated with some meteor sightings are the products of electrical activity. As reported by Science magazine, as a meteor streaks through Earth's atmosphere, it ionizes the air around it, splitting it into heavy, positively charged ions and lighter, negatively charged electrons. The ions follow the meteor, whereas the electrons are deflected by Earth's magnetic field. The separation of positive and negative charges in the meteor's wake produces a large electric field that drives an electrical current. The authors state that the electric current launches radio waves, which are then conducted through nearby objects, producing audible sounds. This explanation brings mainstream scientists much closer to the electric universe interpretation. A key difference is that, according to electric universe proponents, any object that comes far from Earth will be differently charged and can discharge electrically when it enters the atmosphere. In the 2005 Thunderbolt's Picture of the Day article, The Peekskill Meteor, authors Michael Armstrong and Jim Payette suggest that not only the electrophonic sounds of meteors, but also their bright glare, flare-ups, and disintegration involve electrical discharge activity. They state, one proposed explanation with which the electric universe would agree is that meteors and spacecraft trigger the formation of instabilities in plasma layers. The energy of the flickering and flaring, as well as of the low-frequency radiation, comes more from the ionospheric plasma than from the meteoroid. The meteors that we've come to think of as, quote, burning up in the atmosphere may instead be the targets of mini thunderbolts from the ionosphere. For many decades, institutional science has imagined that spectacular meteor explosions occur when fast-moving bolides encounter extreme pressure, heat, and chemical reactions when passing through Earth's upper atmosphere. But this interpretation has left many unresolved mysteries. In fact, the most renowned meteor explosion in modern times leaves many facts that beg for a new interpretation. In 1908, in a remote region of central Siberia, a blue-white fireball, which some described as brighter than the sun, exploded with the force of a 10 to 15 megaton hydrogen bomb. The explosion felled some 60 million trees across an area of 2,000 square kilometers. Yet some trees near the blast center were not burnt, and a ring of burnt trees circling the epicenter was left standing. The thunderous clouds were accompanied by a shock wave that knocked people off their feet and broke windows hundreds of kilometers away. The explosion registered on seismic stations across Europe and Asia, and as far away as Britain, meteorologists registered fluctuations in atmospheric pressure. The resulting pulse of air pressure circled the Earth twice, and astronomers observed for several nights afterwards a glowing red haze in the upper atmosphere, though they were not aware of the cause at the time. Curiously, as noted in the Australian Journal of Astronomy in 1993, the Sir Douglas Mawson expedition in Antarctica reported an extensive auroral display a few hours before the Tunguska event. Many historical accounts also exist of strange weather, including lightning and thunder, and even seismic activity well before the devastating explosion. Despite occasional claims to the contrary, no impact crater for the intruding body has ever been found, nor the remains of an impactor. Though some have occasionally claimed to have discovered Tunguska meteorite fragments. Nevertheless, Tunguska remains officially classified as the largest impact event ever recorded on Earth. In the electric universe theory, the energy released from an intruding comet, asteroid, or meteor is not limited by its mass and kinetic energy, but also the electrical energy due to its charge differential with Earth. This stored electrical energy also explains the astonishing effects of the comet Shoemaker-Levy 9's explosion as it approached Jupiter, including the completely unexpected, dramatic brightening of the gas giant's radiation belts. Similar effects were seen on Mars when the close passage of the comet sighting spring, quote, blew away part of Mars's upper atmosphere. Calculations of the mass and size of the Tunguska bolide, based solely on mechanical considerations, cannot be accurate. These principles were more recently demonstrated in 2013, when a meteor exploded in the sky over the Urals region in Russia. Thousands of homes and buildings were damaged, and more than 1,400 were injured by an explosion that produced as much energy as 24 Hiroshima-sized atomic bombs. The object is said to be the largest to have, quote, struck the Earth since Tunguska. It's important to note that based on infrasound data from around the world, NASA scientists stated that the meteorite had to be about 1,000 times larger than they originally thought based on the object's visual trail. As Wal Thornhill explains in a 2003 article, in the study of meteors, a key element that institutional science has long overlooked is, quote, the connection between ionized meteor trails and electrical discharge activity in the ionosphere. The meteor trail acts as a giant lightning rod that connects the conducting ionosphere to the upper atmosphere. If the Earth is an electrical body in an electrical solar system, it is the equivalent of a temporary short circuit of a giant capacitor. The current flowing along the meteor trail gives rise to the unexplained brilliance and long-lasting glows of some meteors. It causes them to disintegrate like an exploding capacitor, high in the atmosphere. The Tunguska explosion was probably the most noteworthy example of the effect. Increasingly today, scientists are proposing electrical processes as the answers to long-standing mysteries on comets, asteroids, and meteors, revealing a slow yet inevitable recognition of our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.